Springs. Robert Hooke first observed the relationship between the force necessary to compress or stretch a spring and how much the spring was compressed or stretched. The force exerted by a spring is not constant. The more you stretch it, the more force it exerts. F equals negative kx. This is Hooke's law for ideal springs. An ideal spring is one that obeys the above mathematical relationship. The AP Physics 1 equation sheet gives the equation as shown above, with absolute value signs. K is the spring constant. It is measured in newtons per meter. Not all springs are created equal. Some springs are easier to stretch or compress than others. A higher K value is associated with a spring that is harder to stretch or compress. Springs 1 and 2 have the same force being exerted on them by the suspended mass. However, spring 1 has a greater K value, so it doesn't stretch as far as spring 2 does. X is the change in the length of the spring. It is measured in meters. It is not the entire length of the spring. It is just the displacement from equilibrium, how much the spring is stretched or compressed from its natural length. Hooke's law applies for both stretching and compressing. The force required to stretch or compress the spring is equal and opposite to the restoring spring force. This graph shows the relationship between the force stretching or compressing a spring and the elongation or compression of that spring. This mathematical relationship can be experimentally confirmed. The graph can be used to find the force required to stretch or compress the spring a distance x. Small elongations or compressions require small forces, whereas large elongations or compressions require large forces. The spring constant is the slope of the line on the graph. A steeper slope indicates a spring with a greater spring constant, K. Look, y equals mx. And remember, we're going to ignore this negative sign for now. Just pretend it's in absolute values. And you see that if you plot the force on the y-axis and the x, so the compression or elongation on the x-axis, that makes K the slope of the line.